So now that we've looked at the structure and functionality of CyclicBarrier, let's start delving into its key methods. And as you'll see, there are not a heck of a lot of them, which is nice because it makes it a fairly straightforward class. So there's only really a handful of methods that are commonly used. There's some other ones that can be used under certain circumstances, but by far the most common ones are the constructor or constructors, as well as the await methods. There's two of them. So the constructor is used to initialize a CyclicBarrier object, so it'll trip when the given number of parties await on it. And you can see here that parties is a parameter passed to the constructor. And in this context, parties is equivalent to threads. You might think that they are different, but in practice, they have to be the same. CyclicBarrier requires a fixed number of threads where the number of threads is identical to the number of parties. And the reason for this is when you call await on a thread, it blocks. So you're not going to, unless you use a timed await, but even then it'll block for the time period. And as a result, it's really waiting for count number of parties, or the parties number of threads, to arrive at the barrier before it can go on. There's also this optional barrier action that can be provided and executed if it's provided when the barrier is tripped. Now, this is the thing to remember. This is pretty cool, actually. When the barrier action is run, then all the parties, all the threads are suspended until the barrier action finishes its processing. And the reason for that is to avoid race conditions. You've got a bunch of threads running. We don't want to worry about modifying shared mutable state without ensuring that it's properly protected. And why do we use the barrier action? It's used to update any mutable shared state before any parties continue with their processing. And the typical thing you do with a barrier action is you initialize or reinitialize data structures that are shared by the various threads. And we'll see that there's some other variants of doing similar kinds of things to a barrier action, but they're not quite identical. Now, the barrier's count is automatically reset to the initial number of parties after the barrier is tripped. So the way to think about this is after the let's say you have 6 threads you're waiting on, all 6 threads finally show up, that trips the barrier, and what happens at that point, if there was a barrier action, that barrier action is run with all the threads suspended, and then after the barrier action returns, assuming that the goal is to continue moving forward, then all the threads can return from await, and the count is automatically reset to the original number of parties. So after the barrier is tripped and the barrier action, if any, is run, then everything's reset and the whole cycle can begin again. That's what makes this a cyclic barrier, because you can start over again with the beginning number of threads ready. So let's take a look at the key methods. There's really only 2 of them. There's one other one that's sometimes used, but the most popular, most common ones are these await methods. And they basically just block until all the parties or all the threads wait on the barrier, and then they reset it automatically after it's been tripped. Now, the threads that are calling await, when await returns, they get to decide whether to continue on to the next cycle or not. If they want to continue on to the next cycle, they'll go back and call await again. If they don't, if they're finished, then they will keep doing something else and they won't call await. So the simple await call, which takes no parameters, will just block until all the parties arrive, or until the barrier resets, and the barrier resets. When it resets, it returns from await. However, the thread can be interrupted. You can see here that it returns a value, which is an int, and this is the arrival index of the thread at the barrier. So let's say we have 6 threads, and it'll basically tell you the arrival order, and it'll go in reverse order because it count starts out as a number of parties, and each time it gets decremented. So when it finally is done, the final thread that awaits gets a return value of 0. And you can use the return value of 0 as an indication that the barrier has been tripped. Now, that is not quite the same thing as having a barrier action. And the main reason for that is that when the barrier action is called back, all the threads are suspended. When you get back a 0 from await, the threads are off running and doing other things. So this is mostly just useful to log the fact that the barrier is done. You can only use it for something if you don't care that the threads are not suspended. There's also a timed version of await, so you can basically block until the parties arrive and the barrier resets, or the timeout elapses, in which case it'll go ahead and basically return after the timeout. And there is no non-interruptible version of await. So await can always be interrupted. There's no await uninterruptibly, like there was for some of the other methods, like the lock uninterruptibly that we had on a reentrant lock. Now, those are by far the most common methods, await. But there's also a reset method, and that allows some thread or the barrier action or whatnot to manually reset a cyclic barrier to its initial state. You would typically have this done by a thread, not really by a barrier action. And it's just a way to say, everybody break the barrier, and you can decide if you want to keep going or not. If there are any parties that are waiting on the barrier by calling await, they will return via a broken barrier exception rather than the normal return value that is what you get back when await returns. So the broken barrier exception is a way to indicate that something did not return normally. So that's the end of the key methods of Java CyclicBarrier.